Hello and welcome back to another video. In this problem, we're asked to find the inverse function of f of x is equal to x plus 1 over 2x plus 1. So what we have to do here is take the equation that we have, right? Let's set f of x equal to y, because it'll make it a little bit easier to solve. We have y is equal to x plus 1 over 2x plus 1. To solve the inverse function, we have to swap x and y. So this becomes x is equal to y plus 1 over 2y plus 1, right? Y becomes x, x becomes y. And now we just have to solve for y. So we can multiply both sides by 2y plus 1. These cancel, and we're left with 2y times x is 2xy, 1 times x is just x, and this is equal to what's left over here, y plus 1. Subtracting y and x from both sides, these cancel, just to get the y's on one side. We have 2xy minus y equals 1 minus x. Rewriting this up here, 2xy minus y, factoring out a y from this one leaves us 2x, factoring out a y from negative y leaves us with negative 1. This is equal to 1 minus x. Can divide by 2x minus 1. These cancel, and we're left with y is equal to 1 minus x over 2x minus 1. And now remember we turned f of x into y, so we have to turn it back into f of x, except it's not f of x, it's now the inverse function because we swapped x and y. Right? I could have had, wherever we had a y here, writing in f inverse of x every time, but just keeping it as y is a little bit easier. But the inverse function of f is equal to 1 minus x over 2x minus 1.